Okay, for the fifth drawdown, the homework, we got that problem like this. A worker tries to move a rock by applying a 360 Newton force to a steel bar as shown. Now, something to consider. If we review every of the parts, part A, replace the force with an equivalent force coupled system at D. That means at D we want to move a force from here and take it in here. Or B, two workers attempt to move the same rope by applying vertical forces at A and at D. That means instead of having this force, we'll have one force that goes up in here and another force that goes down in here. For C, determine these two forces if they are to be equivalent to the sign of the part A. Actually, this is going to be from the same problem, just a mistake in this part, only two parts. Now, if we review the parts, we actually don't need to know what's going to be the weight of the stone. We don't need to see what's going to be the moment it is creating or the equilibrium it is creating. So we actually can cut out this part of the diagram and only focus on this section since we're actually going to get equivalent system to this force. Having said that, I'm going to enhance and crop. We will just care about these sections. If that's the case, we can get to work for the first one. The first one, replace the force with an equivalent force coupled system at D. So I know we are applying a force of 360 newtons in this position that has an inclination of 40 degrees, 360 newtons. And I want to translate that force to position B. Remember, when we move a force from one point to another in the same object, that's going to create an effect of a rotation or a moment about D. The translation of the force, it's not going to be complicated. The one thing that's going to be the hard part is to calculate the moment of D. Now, as we have done before, instead of getting complicated trigonometrical analysis, we'll just go and decompose this force into two forces. One force y that goes down at the point B, and another force x that goes to the left at point B too. And let's identify the distances we require to create the moments. The distances we require to create a moment with the force y at the point E is going to be of this action line intersects with this distance. The distance we need to create the moment of this force is the one that goes from this application point to this pivot point. If you see, that's equivalent to have a rectangle triangle in here. We can analyze this rectangle triangle. Now, I know this rectangle triangle is going to have 30 degrees angle, and that the hypotenuse is going to be the addition of 0.35 and 0.3 meters from here to here. That means from D to B. We'll have actually 0.65 meters. In order to create the moments, moment about D is going to be moment about D1, plus moment about D2. Moment about D1, I will create it with the distance x, force y. moment about D2, it's going to be created by distance y, force x. Distance x is going to be this one right here. Distance y, this one right here. So let's just calculate the forces and then calculate the distances. The forces, force x, force y, are going to be the total force 360 newtons. For the x, since my inclination is about the vertical, we'll have sine of 40 degrees. For the y, since the inclination is about the vertical, we'll have cosine of 40 degrees. Now, if x, it's going to be 231.4 newtons. Let's make it another color. 231.4 newtons. And forcing y, it's going to be 275.7 newtons. Now, let's go with the distances. The distances, we can calculate as dx equals 0.65 cosine of 30 degrees. dy can be calculated as 0.65 sine of 30 degrees. The resultant distances are going to be, for the x, 0.5629 meters. For the y, 0.325 meters. Having all the information, we just replace in the equations and solve. So moment d1 is going to be dx, 0.5629 meters, times force y, 275.7 newtons. Moment d2 is going to be 0.325 meters. Force x, which is 231.4 newtons. Calculating these values, this will give me a 75.0205 newtons meters. Such an ugly writing. 75.205 newtons meters. And for this one, we will have 155.191 newtons meters. Positive or negative? Well, from perspective of point B, force Fy and this distance are creating a motion that goes counterclock. That means positive. From perspective for D, this force X and this distance are creating also a motion that goes counterclock. Positive. So both are going to be positive. The result when we add these two elements, it's going to be a total moment of 230.34 newtons meters counterclock. That's for part A.